In this tutorial, I'm going to answer this practical question for thermochemistry and thermodynamics. Okay, so being given this question saying, choose the member with the high entropy in each of the following pairs and justify your choice. We assume constant temperature except part E. Okay, so we are going to take note of that. We are accepting part E. Okay, so let's start with the first part. Okay, so being given one more of sodium, sulfur dioxide there, and one more of SO3 there. Okay, so we have one more, everything. The state is the same, the gas state, but what is different is that you notice here you have 2 oxygen atoms, here we have 3 oxygen atoms. Okay, so now if you look at sulfur with a 2 there and sulfur with a 3, oxygen with a 3 there, you notice that this sulfur oxide with a 3 there, okay, it's bigger than this. Okay, so if you are to calculate the molar mass for the sulfur oxide there, you find that you notice that it's smaller compared to the molar mass of the sulfur with the SO3. So now, what does that mean in terms of entropy? Okay, so if you are to compare the molecular weight or the molecular mass of different molecules, you notice that the greater the molecular mass, the greater the entropy. Okay, so you're saying the greater the molecular mass, the more disorderness a molecule you are going to have there. Okay, so in this case, you're going to notice that the answer here is going to be SO3. So it's the one with the higher entropy there because there is increase in disorderness. Okay, so that's what we have. So SO3 gas, the answer there. Okay, so we go to the second one, saying 1 mole of carbon dioxide as a solid and 1 mole of carbon dioxide as a gas. Okay, so we have same number of moles, 1 mole, okay, but this carbon dioxide is a solid and the other one is a gas. Okay, so which one has greater entropy? Okay, so in terms of state, you notice that you have this this range. Okay, so you notice that as you are moving from your solid, okay, going to your gas, so you notice that solid are going to have they are going to have less entropy change, okay, compared to the liquid. Okay, so liquid will have greater entropy change, entropy. So we have higher entropy than solids. And then gases will have greater entropy than liquids there. Okay, so that's what we have. Okay, so if I want, I can put upwards as well. So you have solid, which is going to have less entropy change than liquid, okay, which will have less entropy change than the aqueous state. Then you have gases which are having greater enthalpy change. Okay, so that's what we have there. So here, the one with greater entropy change, the one which is in gas state, because you've seen that gases are actually the one with the greater enthalpy change. So we have CO2 as a gas state is the answer there. Okay, so let's go to part C. Okay, so we have done these two. We go to part C there. Okay, so part C, we've been given 3 more of oxygen as a gas, same state, and 2 more of oxygen, okay, as a gas. So here, the moles, they are different, and also the molecules are different in terms of the weight, okay? So you notice that here, you have this one with the greater weight, but less moles. Then you have this one with the less weight, but greater moles. Okay, so which one do you pick there in that case? Okay, so here we consider the number of particles. The greater the number of particles, the greater the entropy change. Okay, so here you notice that the one, despite having been despite the weight being less, okay, it will have greater entropy because it's having a lot of particles, the moles here. Okay, so the one with greater number of moles will be considered to have greater entropy change compared to the other one. So here we're going to notice that the one with the 3 more of carbon oxygen gas, the one which is going to have greater entropy in that case. Okay, so that's what we have. Okay, then we can go to part D. So part D, they are saying 1 mole of KBr, okay, it's a solid, or 1 mole of KBr as an aqueous. Okay, so that's what you have. So now here you can notice, following this order, you notice that aqueous have greater entropy compared to solid. Okay, so here you're going to have the one with the in aqueous state, the one, since the number of moles are the same, so in this case, the one in aqueous state is going to be the one with greater entropy. Okay. Then here we have the temperature. So we are saying a sweater at 2 degrees Celsius and at 25 degrees Celsius. Okay, at 23 degrees Celsius. So the greater the entropy, the greater the temperature, the greater the disorderedness of the system. Okay, so here you're going to notice that the one with greater temperature, so the one at 23 degrees Celsius, the one which is going to have greater entropy there. Okay, then we do the last part, which is part F. Okay, so part F is saying 1 mole of CF4 as a gas, okay, or 1 mole of Cl4 as a gas. Okay, so here we've been given two things. You have carbon, same number of moles, but we have this carbon which is attached to fluorine, okay, for the fluorine, and we have this carbon which is attached to for the chlorine. Okay, so now we have to ask yourself, between chlorine and fluorine, which one has greater molecular mass? Okay, so you notice that chlorine is the one having greater molecular mass compared to fluorine. So in this case, we'll follow the one with greater molecular mass, which is C attached to chlorine. So chlorine is the one with the greater molecular mass. Okay, so that's how you answer such question. Okay, so thank you so much for watching.